All right, here we are on page 602, looking at problem number 26. And in this problem, we're given an equation in transformation form. Our a is -1, our h is -2, because remember, keep in mind, x minus h is our preset, and our k is 25. And this is a quadratic, so our parent function would be quadratic. And again, a, h, and k to bring it back to module 3. So because I just mentioned that it is in transformation form, aka vertex form, specifically for quadratics, I'm going to use my h and my k to fill out the vertex first. And as we just mentioned, the h is -2, so it's a shift to the left 2 units, and the k is 25, shift up 25 units. Therefore, the vertex of our quadratic would be at that h of -2 and k of 25. Cool. So that is our vertex. Starting off with the easiest thing first. The next thing I'm going to look for is my x-intercepts, and x-intercepts are where y is 0. So knowing that, all I'm going to do now is rewrite this equation with, instead of a y, it being 0. Cool. So now I'm going to go about, after substituting in 0 for y, I'm going to go about solving for x, because that will be my value, or values in this case, my intercepts, where y is 0. So let me erase that out of the mix there. Cool. Zoom in a little bit here so it's easier for me to write. And I'm going to go about solving for x by working to isolate it. I'm going to get rid of addition first. Right now, I'm really executing right now is SADMEP, by the way, for my Algebra 1 students, working backwards using opposites, getting rid of addition with subtraction. Property of equality says if I subtract on the right, got to subtract on the left. When I subtract, what we're now doing is, again, working to just isolate x to find the values of x that make y equal to 0. We're now here. I can get rid of this multiplication in front. And again, that's multiplication of -1. So I'm really just dividing everything by -1, leaving me now with -25 divided by -1, or excuse me, +25. And all we have left now is just x plus 2 squared equals 25. Before I can access this +2, since it's buried inside a grouping symbol inside parentheses, p and PEMDAS, the last thing we do in SADMEP is I have to get rid of this exponent, that's square, by square rooting both sides. And I am going to square root both sides, which will result in 5 or -5, because after all, the square root of 25 could be 5. 5 times 5 is 25. Or -5. -5 times -5 is 25. And that's just equal to now the value that was inside the parentheses, x plus 2. Last step, subtract 2 from both sides of both equations. For sake of space, I'm going to move that bottom equation, -5 equals x plus 2, up. And I'm going to subtract 2 from both sides of both equations, meaning x is equal to 3. There's one of my x-intercepts, excuse me, value of x that makes y equal to 0. Or x could be equal to -7, which is my other x-intercept. When x is -7, we get a y value of 0. Cool, cool. Let me get out of that so it's easier to see the answers. Awesome. The very last thing I need to do is now find my y-intercept. And keep in mind, y'all, the y-intercept is where x is equal to 0. So all I'm going to do is, real quick, let me just get rid of all this extra information. Keep in mind, since this is recorded, hopefully you can go back and pause it amongst any times. You could see that work frozen in front of you. But again, a y-intercept is the value of y, where x is 0. So I'm going to take every x in my equation and sub in 0 for it, meaning what used to be an x here is now a 0. That'll allow me to solve for my y-intercept. At this point now, I have y isolated. All I have to do is use order of ops, aka PEMDAS, to solve this down. No need for SADMEP because I already have my unknowns isolated. So PEMDAS says we do parentheses first. 0 plus 2 is 2. PEMDAS then says after parentheses comes exponent. Keep in mind that that's squaring the parentheses, so the negative is not touched yet, and 2 squared is 4. And now all we got to do is add up -4 and 25, and we get 21. Thus, when x is 0, y is 21, and that is your y-intercept.